Hello, today's video is an introduction to derivatives. Let's get started. So we know that the slope of a line, of a linear function, so this is y is equal to mx plus b, slope is m, and we can find m various ways, but most common is probably m is equal to y2 minus y1 over x2 minus x1. Rise over run, right? You have 1 point here, you have 1 point here. You use the difference between the y values and the difference between the x values. Take that and you get the slope. Well, what if we have a function like this? F of x is equal to x squared. So this looks like this. Okay, pretend this is touching. Maybe we'll say this is x squared plus 1/2, right? But we want to find the slope of this function, and we can't use this equation anymore. I mean, we can, but it would be between 2 points, and that would give us a straight line, and that's not what we're looking for. We want the slope at a single point. Imagine there's a tangent line here. We want the slope of that tangent line. Now, to find this, first we're going to introduce derivatives, how it's typically done, which is just by using limits, and then I'll introduce some rules. So we define the derivative. I guess this is how we define the derivative. The derivative f prime of x, that's how we denote it, is equal to the limit as h approaches 0 of f of x plus h minus f of x over x plus h minus x. And we end up just getting limit as h approaches 0 of the difference between the values over h. Okay. So as you can see, we're still using this formula, right? We have, this is basically y2 and this is y1. This is x2 and this is x1. So you can imagine we draw, so if this is x, okay, and this is y, then there's going to be some point on this tangent line, and that point we're going to call this point x plus h, f of x plus h. And so what we're doing by taking this limit as h approaches 0 is you can think of, if h is way out here, then our slope is going to be kind of inaccurate, but we're moving h as close to x and y as possible. H specifically, we're moving as close as possible to x. That'll change the value and make the value as close as possible to y. So with this formula, let's look at an example. This time we'll just stick to f of x is equal to x squared. Okay. So using this formula, we can find that f prime of x, the derivative of f, is equal to x plus h, so you substitute that in for this x squared, minus x squared over h. And I didn't mention it before, but as you can see, these x's are going to cancel always, so we can just simplify it by writing this. Okay, and this is going to be equal to x squared plus 2xh plus h squared minus x squared over h. And this is going to be equal to, the x squares are going to cancel out, and we can factor out an h here, so we're going to be left with h, 2x plus h. So these h's are going to cancel out, and we're going to be left with limit as h approaches 0 of 2x plus h. So as we can see, this is going to be equal to 2x. So the derivative of this function is equal to 2x. Hopefully that makes sense. Okay, so now we're going to cover some derivative rules. There's a handful of them. Don't worry, with practice, it'll become a lot easier to remember these. It'll become second nature to you. So as a reminder, we define the derivative as such. Now, we have some rules. We have the constant rule, and these have several names, so don't, don't bully me for using something that your textbook might not use. So d by dx, now this is another way of saying take the derivative. So take the derivative, we'll say this is the same as d dx of f of x. And sometimes you'll even see it, well, a lot of times you'll see it written like this. So these are all the same here. Anyways, constant rule, d by dx of a constant c is equal to 0. This is always true. No matter what number it is, if it's just a constant, there's no variables attached to it, it'll be 0. This one is a crowd favorite. You will learn to love this one. It's super helpful for polynomials. This is the power rule. And so when you take the derivative of something that is x to the power of n, you get n times x to the power of n minus 1. This is always true. And so if we look at our previous example here, I'll just show it real quick. Our function was x squared, right? And our derivative ended up being 2x. So you bring the 2 down, 2 times x to the power of 2 minus 1, which is 1. All right, so you've got the constant multiple rule. Which says that d by dx of cy is equal to c dy dx. You can just pull the constant out and then do the differentiation. You've got the sum rule. And this works for differences as well, so whether it's positive or negative. But let's say you have a function y and you have a function z. In fact, no, this is fine. This is the same as dy dx plus dz dx. Then you got the product rule, another crowd favorite. So what happens if you have two functions being multiplied together? So you have d by dx of y times z. Well, now you're just going to take dy dx times z. So you take the derivative of the first times the second plus the derivative of the second, so dz dx times the first, y. So that's the formula for the product rule. Now there's also the quotient rule. I'm not crazy about it, but it's important to remember. There's a way you can get around it by using negative exponents, but for now I'll just write this down. If you have d by dx of this, y divided by z, and where y and z are functions of x, then you're going to get the derivative of the first, dy dx times the second, z, minus the derivative of the second, dz dx times y, over the denominator squared. Notice it's not the derivative of the denominator, it's just the denominator squared. All right, and now there's one more really important rule that we're going to cover called the chain rule. So I'll note that these are really important. A lot of the other rules can sort of be derived from these rules. So anyways, here we go. Chain rule says, let's say you have d by dx of, let's say you have a function f, and it's a composed function, a composite function. So you have the function g of x in here inside the function f of, you know, whatever. So you have f of g of x. Okay, so this is going to look like f prime of g of x times g prime of x. So it's called the chain rule because you chain the derivatives. So you take the derivative of the most outside piece first, keeping the inside bits the same, and then you multiply by the derivative of the inside bits. And you just keep doing that. So if you had a long chain, you would just keep doing that over and over again. Now we're going to take a look at one quick example. Let me see if I can do that. One quick example. The first thing we're going to do is we're going to recognize that we have two functions here. So this is equal to so these are the same here. Now notice I've taken this 1 over 3x and turned it into a negative exponent. I've done this so I can use the product rule instead of the quotient rule because I like to work with the product rule a lot more. So let's do this. Okay, the derivative of the first, right? So this is going to be negative 1 times 3x to the negative 2, right? Times the first, x, or times the second, I mean. Okay, plus the derivative of the second, so using the power rule, this is going to be 2x plus 3x, and then 3 minus 1 is 2. 3x squared multiplied by the first. Yes, sorry, made sure I had to do that. Okay, so what are we going to have? We're going to have negative 1 over I feel like I've perhaps done something wrong. Yes, it's because you can take the 1/3 out. So negative 1/3, right, times 1 over x squared. That's how that ends up looking, sorry. Right, x squared plus x cubed plus 2x plus 3x squared over 3x. Now you can do the math and we can end up simplifying this down to 1/3 plus 2/3 x. Always remember to simplify because you can get things to look a lot prettier. I know I skipped a lot of steps there, but take it as a chance to do it on your own. Yeah, and so that's going to be the conclusion to my first video on derivatives. I'm going to cover a second video where I'm going to talk about some logarithmic and exponential functions and their derivatives, as well as the rules associated with those. I'm also going to cover, do a separate video on trigonometry, trig derivatives, and even some hyperbolic trig, inverse hyperbolic. It's going to be a doozy of a video. And with that, hope you have a great day. Thank you for watching.